Greetings. We're going to do Chapter 5, Section 6, the remainder and the factor theorems. We've already touched on this when we did synthetic division. I think you'll find it to your liking. It's actually a shortcut for solving functions for a value. So I'm looking forward to it. Hopefully you are too. The remainder theorem says that when you divide a polynomial f of x by x minus a, your remainder is actually what you get for plugging that value in that went in your box. So remember, this means I'm going to put x equals -2 in the box, and I'm going to put -2 in here, and then to the fourth, to the third, to the second, to the first, constant, leave a space, and then this remainder right here will actually be the same thing as f of -2. So you got to remember how to synthetically divide. Drop the 3, multiply, add, multiply, add, multiply, add, multiply, add. Now that means that the remainder is the same as f of -2. So if we were to check this, we would grab our trusty calculator and do that, and that, and that, and that, and that. And when I solve this, of course I don't have a trusty calculator, so let's see. This is +16 times 3 is 48, plus -2 to the third is -8, and 2 is -16, and 2 squared is 4 times 5 is -20, and this is -2 minus 2. And it looks like I got -36, -38, -40. So I got 48 minus 40 is 8. Ta-da! What this does for us now is it gives us a way to find f of a value by using synthetic division rather than doing these big nasty plug-ins. So synthetic division is so much easier than doing that. This is a shortcut, and y'all like shortcuts. I'm sure of it. This is called synthetic substitution now. Synthetic substitution. So I'm going to put -5 into the box, and -3, and +5, and -1, and this will be my answer, and drop it, and multiply, and drop it. Holy cow. This escalated quickly. -3 times -5 is +15. Added is 20. 20 times -5 is -100. And -100, and that means that we would get -101. F of -5 is -101. That's good stuff. Do the same thing for f of a half. Oops. Put a half in the box, -3, 5, -1. I guess I usually dot that, don't I? There's your answer. Drop it. Multiply. Add. It's 10/7 minus 3/2. 7/2. We love fractions. A half times 7/2, 7/4. This is -4/4 plus 7/4, 3/4. So my answer for f of a half is 3/4. So if you don't believe me, you can plug those into f of -5 and f of +2, but I think this is pretty great. Same idea here. You do have to remember. Okay, so we're doing the same. Back to some synthetic division rules. To the third, degree 3 term, degree 2, degree 1, and constant. You got to remember that you got to put that 0 in there. Drop it. Multiply, add, multiply, add, multiply. That's 200? You kidding me right now? And my answer is 195. I guess we got a cubed up there. Cubed would mean negative 125, and then negative be positive, and then we square. Oh yeah, this is good. That would work. Yep. I trust the process. Always trust the process. 1/2. And again, we're using, don't forget the linear term. Whoops, that was bad. Negative 1, multiply, add, what's that? 6 over 2 minus 1 over 2, 5 over 2, multiply 5 over 4, add 5 over 4, multiply 5/8. 5/8. So I got negative 5 and 5/8. What's that? Negative 4 and 3/8. That's not bad. Way better than plugging in. Good stuff. Synthetic substitution. Hopefully you're enjoying this as much as I am. Factor theorem. It's directly related to the remainder theorem. The binomial x minus a is a factor of the polynomial f of x if and only if f of a equals 0. So if you get a remainder of 0, then what you started with is a factor. So we can factor completely by using this. Here we go. Put your 2 in a box. So I'm going to put a 2 in here. And I'm going to have, excuse me, 1, that's the cubed, squared, linear, constant, and we go like this. And then we drop it, and we multiply it, and we add it, and we multiply it, and we add it, and we multiply it. And they kind of told us that this was going to be one of its factors, so this shouldn't surprise us. It tells me that if f of 2 equals 0, then x minus 2 is a factor. That's what they're saying. Now, this was a cubed, so now we can go down here and put the answer down. X squared plus 3x minus 4. So what we're going to do next is we're going to factor this thing. What do you multiply together to get negative 4 and add together to get 3? I think it's x plus 4, and I think it's x minus 1. So we're back to factoring, which is some of the most fun you can have in math class. So my answer is find the remaining factors. So really you've got 3 factors. You have x minus 2, x plus 4, and x minus 1. So just by knowing one of the factors, you can quickly turn it into a quadratic, which then makes it into a factorable quadratic, and boom, there you are. Good stuff. Given the polynomial and one of its factors, find the remaining factors. Okay, so this is where, so we're utilizing this now. Like, we couldn't factor this right now. That just, it's not feasible. But when you know one of the factors, this will give me a remainder of 0. Otherwise, they've failed at their problem-making skills. This should be 0 over here. 3, negative 4, negative 5, 20. Uh-oh. What? Uh-oh. Did I make a mistake? 3, negative 1, negative 62, negative 40, and I got negative 4, and I draw. Oh, jeez. I'm a terrible math student. Made a mistake. First mistake of the year. Negative 4. I don't know how to multiply. Things are bad when you don't know how to multiply. Let's try that again. Try not to make any mistakes. Negative 12, negative 13. And then you've got negative 13 times 4, which must be like 52, right? 52, which then gives me my negative 10, positive 40, and 0. So now I have 3x squared minus 13x minus 10. And now we're going to factor this. So I'm looking for factors of negative 30 that add up to negative 13. Remember, you got to multiply a times c. So some of you that still despise factoring, it's time to get over it. And I believe that that's going to be what? Negative 3 and negative 10. So I'm going to go 3x squared minus 3x minus 10x minus 10, and you can almost see it coming. I put a plus in between there. I take a 3x out, I get x minus 1. I take a minus 10 out, I get x. What happened here? What happened? Minus 10 plus 13. Took a 3x out. Isn't it negative 3 times negative 10? Holy cow! I made another mistake. Okay, I got to erase that black part there, and I just don't know how to do it. So let's go 3x squared minus 13x minus 10. This is what happens when you try to do videos when you're sick. 3x squared, what was it? Minus 13x minus 30. That's not 13 and 3, you genius. That's negative 15 and positive 2. Boy, check your math once in your life. Holy cow. 3x squared minus 15x plus 2x minus 30. This is going to work a lot better. Boy, I was talking pretty smart back there, thinking I knew what I was doing. 3x, x minus 5, 2x minus 50. What's going on? There's something extremely upsetting about this one. Assuming that I've done this right, then this isn't actually factorable. So let's see here. Is 3x squared? I got to go back and start it over again because maybe it doesn't work. Given the polynomial is one of its factors. It says it does. Negative 4, 3, negative 1, negative 62, negative 40. Okay. Put the line. Drop the 3. Multiply. Negative 13. Positive 52. Negative 10. Positive 40. 0. Oh, it's 10. I had 30 because it's not good. So what do you multiply together to get negative? Oh, there's the 30. So it's negative 30. Positive negative 13. Hopefully you're getting a good chuckle out of this. It's not funny. I got negative 15 and positive 2. And now it's 3x squared minus 15x plus 2x minus 10. And we group, and we group, and we get 3x. Oh, this took a while. And x minus 5. And there it is. Whoomp. There it is. Looky there. How do you like me now? X minus 5, 3x plus 2. So my three factors are those two and that one. Oh man, holy cow! I'm gonna need a breather after that one. Anything else on this guy right here? No. Do those problems. It shouldn't take you very long. When you get done with your homework, please make sure that you work on something else for another class quietly. 355, 8 through 22. Go.